Hey there and welcome back. I hope you thought a bit about this problem we have when the words are out of, sorry, not the words, but the letters are out of order. And the sentence that I just said, says it all. It gives the answer away. We are talking about things that are out of order. Or in other words, we would like to reorder the letters here so that when we do the progressive membership, we give priority to the words that are already correct, which in this case were the trailing S's in chess and Swiss. Now, there's plenty of ways of solving this. I'm not saying that the way I'm about to show is the only way to do it, but one thing I thought of was if we compare the secret and the guess directly, and okay, let's just compare it. The thing we get is a Boolean vector that tells me which letters are the same. Now, if I do a grade down on that, this is a permutation, so this is a set of indices, and these indices in particular, they move the letters that are the same to the beginning. Notice that the 3 and the 4, these are the indices of the numbers 1. And all other indices go in order because the other letters are left untouched. So if I save this as P for permutation, if I take the secret word and I index it with P, then this is the word chess, but the two S's are in the beginning. Or if I take the guess and I index it with P, these are the two trailing S's, and this is the beginning of the word Swiss. So now, if I were to do progressive membership with these two words, with the ones that have been reordered, secret P, now the 1 here, this refers to these two S's, which are correct. And then the third S has a 0. So this is better, except that now the score is out of order. So now we need to fix this. And in APL, when we have a permutation like P, the inverse permutation is the grade up of P. And maybe from the numbers it's not obvious, but it will become clearer when we try it out. So we have the guess that has been reshuffled. Now if we index it with the grade up of P, we see that Swiss goes back to normal. And the same thing with the secret. Now we get the chess. So we are going to need this permutation vector because we need the permutation vector to shuffle the secret and the guess around. Then we apply progressive membership, and then we reorder things with the inverse permutation. Right? So this is our solution. So this tells me, what do I want to show? Yeah, so this is the right portion of the solution to create the score, and then we just need to add the secret equals the guess. And this gives me the correct score. Now, we need to write this in here. Let me think. I don't love the brackets here. The brackets around the parentheses. This becomes harder to read, so you can't really tell what's starting where, or, well, I just prefer when it's nested. So let's do the following. Let's write this simple function called I for indexing, and it's just the chipmunk idiom. So this is just a function that takes a series of indices on the left and picks them from the vector on the right. So for example, if I have P, I can index into the secret word, or if I have P, I can index into the guess word. Right. And now, if I grade up P, I can index again and I can undo what I just did, or the secret here. So now the I with something on the left is kind of substituting for the brackets with the indices in there. So now our solution, this expression becomes, first P is So P is what? It's the grade down of the direct comparison between the guess and the secret. And then what we do is the guess equals the secret plus the grade up of P indexing into the guess progressive membership on the secret, except that when we do progressive membership, first we need to pre-process both arguments, and we pre-process them with what? With the index by I. So this is our solution. Now this is long because the words here are long, but if I write this in the score function, P is the grade down of the direct comparison of the two. And then what we need to do is we take the two, compare them, and add that to the grade up of P index into the, now the secret word, let's have it on the left. So the secret is alpha, so the guess is omega, progressive membership over the pre-processing with the reshuffle. So this is our score, and if we have the secret word, we can score our guess. So let's say something like AB, ABC. Now let's score something like AA, BBC. Alright, so this seems to be respecting everything. Now, what if I have a bunch of A's? Now notice that the second A is this one, which is being matched up correctly with this one, and this one is being ignored, so everything is fine. Now what if I have a C in here? So now the C has a 1 because we know it shows up somewhere, and this A is out of place, it should be this one, and this A is correct, so that's a 2. Or maybe if we move the A to the end, notice how these A's in the middle are completely ignored. So the score function seems to be okay now. Alright, so now that we know how to score, and now that we've taken a look at things like progressive membership, the tagging function, which was very important to create a progressive membership function, and this function to index, we are ready to tackle the main function that we want to implement, which is the filter function, which is going to work on a matrix of words to help us play Wordle. So we'll start working on that function in the next video. See you soon!